While building atomic models into low-resolution maps can be very challenging, the availability of higher-resolution models of homologous proteins can simplify the task substantially. Here we are looking at 3FYJ, an 11-year-old small 3.8 angstrom model deposited with minimum refinement. 15% of the residues are Ramachandran outliers and 18% are Rotamer outliers. While correcting these errors manually would be quite time-consuming, here I will be making use of the 1.9 angstrom model of a 75% identical homolog, 3FHR, to quickly correct the majority of the problematic sites. Note that as deposited, 3FHR itself contains some correctable errors, but given the much higher resolution, these were straightforward to correct with modern methods. The reference model shown as a cyan ribbon here is 3FHR after rebuilding and re-refining. Since reference models are rarely in exactly the same conformation as the model you are building, it is often most sensible to apply restraints in torsion space. In order to avoid over-restraining in the face of real conformational changes, these are implemented as top-out restraints that reduce their strength once a deviation grows too large. The restraints are applied using the ISOLDE restrain torsions command on the ChimeraX command line. The width of the restraining well and the rate of fall-off in the top-out region are both adjustable. Since the goal in this case is to quickly improve a severely deviating model, here I make them quite aggressive. These parameters can be adjusted at any time with the ISOLDE adjust torsions command. After selecting the whole model and starting a simulation, we can get an overview of what happens by watching the Ramachandran plot. The bulk of the rearrangement actually happens in the first few seconds in the pre-simulation energy minimization. The remainder settles over the course of the next 10 to 20 seconds. At this point, it is often sensible to reduce the temperature from the starting 100 Kelvin down to near absolute zero to reach a more energy minimized state. While the Ramachandran plot has drastically improved and the fit to data is also looking better, it is very important to remember that restraints like this should be used as an aid rather than a replacement for manual rebuilding. At this stage, the model still contains correctable errors. Most of these occur in sites where the reference sequence is different from the model, others where the starting model was simply too far from correct for the restraints to take hold, and some where the model conformation is genuinely different from the reference. In these latter cases, it is sensible to selectively release the disagreeing restraints via the use of the ISOLDE release torsions command. However, where the model and reference do agree well, keeping the restraints active generally does lead to an improved result even after the model has settled to the new conformation.